All right, is this working? Yes, it is. Okay. All right, so this is a video for slide 6 because we ran out of time. Sorry, in class. Okay. All right, so when you see a velocity graph, okay, that looks like this, all right, this is still a positive velocity, right, because it's above the axis, okay? So the initial velocity is 10 meters per second. That's still a positive velocity, and it ends at a velocity of 0, okay? So even though this line has a negative slope, right, that means it has a negative acceleration. It's decreasing its velocity, but it's still in this part of the graph that's for positive velocities, okay? So this is still moving in a positive direction, okay? So this would be moving in a positive direction, okay, and slowing down, okay? All right, so if I want to know the displacement, right, remember I'm just going to find that area of that triangle, okay? All right, so the area is 1/2 base times height. Okay, well, let me write displacement. Okay, so that is going to be the displacement, 1/2. Okay, that base of that triangle is 5 seconds long. Okay, and the height of this triangle is 10 meters per second. All right, so 1/2 times 5 times 10, so 50 divided by 2 is 25. And remember, the seconds cancel, so that's going to be a total displacement of 25, right? And it's going to come out positive 25, because it's still above the axis. It's still moving in a positive direction. Okay, so when I go to make my position graph, 1, 2, 3, 4, 5, 1, 2, 3, 5, 10, 15, 20, 25, 30, however you want to label this. Okay, 5, 25. So after 5 seconds, it will have gone 25 meters. Okay, right? If I draw a straight line on a position graph, that means constant speed, okay, which it's not, all right? If I draw a curve this way, right, those tangent lines are getting steeper, so that would be a speeding up, which is not. Okay, so then my other option is to connect with a curve that's facing this way, okay? Because here, if I want to take a look at those tangent lines, see, it starts off here very steep, and then it gets more shallow, which means it's slowing down. That's how you see slowing down. Okay? The acceleration you find from the slope of the velocity graph. Okay, displacement was from the area of the velocity graph. Okay, so if I choose 2 points here, which will be 0, 10, and 5, 0, okay, just the starting and ending point, and then I just find my slope. Okay, 10 minus 0, that's meters per second on the top. Okay, divided by 0 minus 5 seconds on the bottom. Okay, so you see that's going to be a -5. That's how I'm going to get a -2, right? Because I'm decreasing my velocity by 2 meters per second each second, right? So when I look at the graph after, let's see, where's 1 second? Oh, this is kind of a weird graph. No, it's not. 1. Okay, after 1 second, right, I went from 10 to 8 meters per second. After another second, 6. After another second, 4, 6, 8. And then after another second, 2. And after another second, stopped. Okay, or a velocity of 0. All right, so that's why it's negative acceleration, because it's slowing down. In this case, because it's moving positive. All right, okay, next one. All right, this one's more like the one that we saw. This is a regular velocity graph like we saw in the lab. So this is still moving in a positive direction, okay, because it's still above the axis here. All of these numbers up here are positive. Positive direction, and this is speeding up, right, because the velocity starts at 0, and then it gets to some higher value, okay? All right, so again, if I want to find the displacement, I'm just going to use the area of the velocity graph. Okay, so 1/2 base times height. All right, my base of my triangle now is 6 seconds. And the height of my triangle is, looks like 20 meters per second. Okay, so 1/2 of 6 is 3. times 20 is going to be a positive 60 meters. Right? This is meters, right? Was this one meters? Yeah. Okay, good. Okay, so again, on my position graph, 0, 1, 2, 3, 4, 5, 6, 10, 20, 30, 40, 50, 60. That's convenient. Okay, right? So this point here, after 6 seconds, I would be at 60 meters. Okay, and I started at a position of 0. Oh, whoops, which I didn't say. I guess we have to assume that. That was not good. Okay, you don't really know where you started, but we'll just assume 0. All right, and again, a straight line here in the position graph would mean constant speed, which it's not. It's supposed to be speeding up. So you want to think about how you have to connect those points to get it to show speeding up, and that's going to be the upward facing curve like this. Okay, and again, when I look at those tangent lines, it's going to start out more shallow and then end more steep, right? Which means it's getting faster. Okay, all right, and the acceleration is going to be the slope of the velocity graph. So I'm going to have my point 0, 0, and then 6, 20. Okay, so if I just simply find my slope here, 20 minus 0 meters per second, because that's my velocities on the y. 6 minus 0 seconds. Okay, which is 20 over 6, which is like, what, 3.6? 3.7 by 6, 3.3. Okay, which is a positive 3.3 meters per second, right? So every second that passes, right, 1 second up 3.3, 1 second up 3.3, 1 second up 3.3, all the way till you get to this final velocity at 20 meters per second. Okay, all right, so there you go. That's basics of what you need to be able to do. All right, you want to be able to use the area of the velocity graph to find the displacement and the slope of the velocity graph to find the acceleration. Okay, and then once you know this value here, you want to be able to draw the position graph. Okay, and then you should be able to know if they're always going to be moving in a positive direction, hint. Okay, we're not doing anything in a negative direction that's changing speed. They're always going to be positive. Slowing down looks like that. Speeding up looks like this. So make sure you know those two shapes. Okay, all right, there you go. Now how do I turn this off?